I'm hitting record.
Hello, ECE 3710 fellow colleagues. We're making the Galaga game, and with this game, we're have a ship, and we're trying to move around, and kill aliens by shooting, by moving left and right using the FPGA or the Bluetooth Connect. But we're Group 9 with Colton Watson, Christian Giauque, Nathan Hummel, Benjamin Leaptrot, and um, the flow. So this is our flow chart and how we initialized and made the game work is we had the initial screen set up, which was the VGA, and then we read it from the phone that went into the reading from the phone. And then we had the process of having to either move right or move left or press A. And then by pressing A, we would create a bullet that would create it from the ship. And then it would go up and shoot the aliens. And by which would update the board each time we move left or right. And then we would check for the collision if the bullet went up and actually hit the alien. And then it would draw the next background for every time that we either would move left, or I mean, when we shot the alien and we would start shooting, and then we would update the position afterwards after the draw background. And then it would rinse and repeat back to the read from phone, and it would go through this whole chart consecutively till all the aliens die, and we get a final score. Thank you, and we'll move on to Nathan talking about memory.
All right, awesome. So this is how we laid out our memory on our FPGA. So we started off at the top at 0x0000, and we started there with the code and added ample space for the code. And I don't think we ended up using even close to all of it, but had it there anyway. And then in the middle portion, this is kind of where it was the interesting part, where we kept all the game data as far as important variables, positioning of the ships, and whether or not the ship had shot recently. And then at the bottom, we had the VGA memory, which included the giant board that we had. Just kind of getting a better look here at the variables that we had. This is kind of just a sample of what it looked like. So at the top, we had all the different variables that we needed for the ship and that we needed to keep track of throughout the game, as well as the score and all the different enemy ships, because we have up to 15 different enemy ships on the single screen at a time. And each of those we need to know if they're alive and where they are, if they're alive, so that we can hopefully, as Christian said, take them down, kill some aliens. And with that, I'll turn the time over to Colton to talk about our assembler.
Okay, so for our assembler, we decided to, let's see here. We decided to focus mostly on trying to keep it as simple as possible with, now my screen's flashing. That's great.
Live demos.
Live demos, yeah. So, I actually have control of my computer. There we go. So, the assembler accepts comments, instructions as they're presented in our instruction set architecture. We also have allowed for adding this instruction, which tells Verilog when compiling the code to jump to that location, keep writing. Let's see here. To use the assembler, you use it similarly how you would like GCC or any other compiler. So if we give it the file, it will compile, and then if we look at the document that contains it, it'll have the corresponding hex code. And with that, I will turn it over to Ben.
Hi, everyone. So I'm going to be showing how we designed some of the peripheral for the system. So we designed an Android app through Android Studio to kind of replicate an NES controller. We got all of the different directions, start, select, A, B. We are communicating to the FPGA through an Arduino here, and this is the Bluetooth receiver that communicates to the Arduino, which sends a parallel signal to the FPGA. The reason we decided to do a parallel signal was to simplify reading from the Arduino. And so then we just incorporated it into the data path to write to a register. And we incorporated an instruction specifically for it. And so then this is our screen, as you can see here. Currently, we have the ability to move right. Left can be done. It is a tad bit challenging, but it can be done. Shooting is on its way. And let's see here. And I think that's it.
Awesome.
How much time was that?